Good evening, everyone. This is Dr. Dong. Today, again, I'm going to sit at home and discuss our slides. So, actually, if you remember that in the first lecture, I said that in a semester, our course is going to consist of four parts. So the first part is sorting algorithms, and we already finished that, and so in which we learn four sorting algorithms with different complexities. And in the last 2 weeks, we focused on basic data structures. So we learned four different structures, which include stack, queue, linked list, and binary search tree. So stack, queue, and linked list are very efficient at insertion and deletion because they provide very efficient. The insertion and deletion complexity are O1 is like no matter how many elements are there in the data structure. If you just want to insert a single element, it takes a constant time. So and then for binary search tree, if you remember, that we said that's the main purpose for us for people to design this data structure is because it provides very efficient search operations. So we said that the search complexity of binary search tree is OH, where H is the height of the tree. And also, if you remember, we said that H is in the so H is larger than or equal to log n, but less than n. And also, in most cases, in general, it is very close to log n. It's going to be at the small side. Okay, so which means that in most cases we will be able to get log n search complexity from binary search from binary search tree. So, and let's look at all the complexities that we have learned so far. So I'm going to write them down from the lowest to the highest. And so the most efficient complexity or the smallest, lowest complexity that we have learned is O1, constant time. And then we learned O log n. So that is the search complexity for binary search tree in general cases. And then we learned On plus K complexity. Okay, so we learned this complexity from counting sort, where n is the number of elements in the array and k is the largest value in the array. So, and also we learn On log n complexity, and also we learn On square complexity. We learned On log n complexity from merge sort and On square complexity from insertion sort. So far we have learned 5 complexities. Okay, 5 time complexities, and let's just keep them in mind. So today we're going to enter the third section of our course, which is dynamical programming. So in my opinion, dynamical programming. So it's just let me just make it straight. Okay, if your dream job is software engineer, is to be a software engineer, and this is going to be most likely this is going to be the topic. Dynamical programming is going to be the topic that decides if you can get a job or not. This dynamical programming is the most frequently asked questions in coding interviews because it is relatively easy for you to implement an algorithm by using dynamical programming. I mean, from the coding side, okay, there is no challenge, or the challenge is very small. So you don't need to use additional data structures, or also you don't need to like refer to libraries, but it's very hard for you to derive a solution based on dynamical programming, especially with a very short time period. Let's say 45 minutes or 50 minutes. That is the usual time limit for each round of coding interview. It's really hard to come up with a solution by using dynamical programming. If you can come up with a solution based on dynamical programming in that small time, it means that you have a very solid computer science logic, and that is the thing that your future employer is going to ask for. Okay, for programming languages, it's just a matter of time. I mean, So like if you practice more and if you do more projects, you'll be more familiar with that programming language. And these things can develop with when time goes by, okay? But the logic, the computer science logic is I would say it definitely needs some intelligence, and also it needs some let's say talent, okay? So if you can find, if you demonstrate that you have this kind of talent, they are going to hire you definitely. So that's why I said that especially for those of you who want to be a software engineer, just pay extremely high attention in these two lectures, in the lecture of today and the lecture and also the next lecture. So it will help you a lot. So let's look at so before we step into dynamical programming, let's look at a design philosophy that we learned previously. We said previously we learned a design philosophy named divide and conquer. So in divide and conquer, we say that we solve the problem in 3 steps. Let me just use merge sort as an example. If we were giving a very long array, in the first step, we divide it into 2 smaller ones, and next we're going to focus on these 2 smaller ones, and we further divide them until each of them just includes a single number. So after that, we're going to combine them. Okay, so this is merge sort, right? And okay, one thing that you need to note is that at each step we divide a bigger problem into two non-overlapping smaller problems. So what do I mean? If we just look at here, okay, with this divide, we got 2 smaller arrays which are here and here, okay? Do these 2 smaller arrays have any overlap or not? Do they share any part? No, they're just disjoint, okay? So okay, when we are trying to break a big problem into disjoint sides, into disjoint smaller problems, we can use divide and conquer. And so in the other case, when there is overlap between the different sub problems, then we need to use dynamical programming. I'm going to discuss that later, okay? And here, I just want you to know that dynamical programming is kind of like similar. It's similar to divide and conquer. So the general idea is that instead of just working on a very big and complicated problem, we want to reduce the difficulty by just working on smaller problems or sub problems. Okay, so the general idea behind these 2 design philosophies do have some similarity, but still they're different. So so here you can say that dynamical programming is to break the problem into several overlapping sub problems. And I'm going to show you, okay, what do I mean by overlapping sub problems. Okay, so and if you look at the textbook, these are the 4 steps that we are going to use to solve a problem by using dynamical programming. But again, this is very like formal or abstract. It means that if you just read these sentences, probably you don't know what are they talking about. Okay, so my task is just to like explain these steps and make it easier for you to understand. So to do that, I'm just going to use one example. Okay, so let's look at the rod cutting problem. So the input is that, okay, so here is a table, is we can take it as an array. Okay, so the index starts from 1 and ends at 10. So what does it say? Okay, so here we have the first value in the array as 1, the second value in the array as 5, and etc. etc. What do they say? It says that, okay, if you have a rod whose length is 1 inch, you'll be able to make, and if you sell that rod whose length is 1 inch, you can make $1. And if you have a rod whose length is 2 inches, and if you sell it directly, you'll be able to make $5. And for a rod of length 3 inches, you'll be able to make $8, etc. etc. Okay, so here basically from this array, you will be able to know the price for rod of different lengths. So then the problem is that, okay, suppose here you are giving a rod of length n. N can be any number, can be 1, can be 2, can be 100. So the question is that how are you going to split so here you are allowed to split a very long rod into smaller ones, and your objective is to find the best way to cut a very long rod, just in order to make the most money from that. Okay, so here let me give you an example. So suppose here we have a rod of length 4. We have a rod of length 4. So let's just discuss some solutions, a couple of solutions. So if you do not cut it, if you just sell this rod as a whole piece of length 4, a whole piece, you will be able to make according to this table, you will be able to make $9, because for a rod of length 4, if you sell it directly, you can make $9. And the other solution is that, let's use one extreme case. Okay, what if we just split this rod into 4 different parts, and each part is only 1 inch long? So how many dollars can we make from that? So for the first part, because each one of them is just 1 inch, and for each of them we can make $1. Okay, so in total we make $4, and which is definitely worse than just selling it directly, right? So here let's consider another solution. What I'm going to suggest is that, okay, why not we just split it into two in the middle. Okay, so we got 2 inches over here and 2 inches over here. So according to this table, okay, if we sell a rod of 2 inches, we will be able to make $5. So here we got a $5 plus $5, and so in total we make $10. Okay, so it seems that, okay, here I'm just listing 3 different options to cut the rod, and here you can say that these 3 different options give us different revenues, and they differ a lot. So our objective is to find the best way to cut a rod and to make the most money from that. So how to do that? Some of you may say, okay, let's try all the possible ways to cut the rod and check, okay, for each way how much money can we make, and then we will be able to find the best solution, right? Yes, this way is definitely going to work. It will help you to find the best way to cut a rod. So here let's look at how many different solutions or how many different possibilities of cutting a rod of length 4. So here I'm just going to show you all the options. So the first option is right over here. We just sell it directly without any cut. We will be able to make $9. And if you cut it into 1 inch and 3 inches, so we will be able to make $1 from the 1 inch and $8 from the 3 inch. So in total it gives us $9. And if we cut it into 2 and 2, we'll be able to make $10. If we cut it into 3 and 1, we'll be able to make $9. If we cut it into 1 and 2, we'll be able to make $7. 1 to 1 is also going to be $7. 2 1 1 is also going to be $7. And if we cut it into 4 parts, where each part is only 1 inch long, we'll be able to get $4. So after we enumerate all the possibilities, we'll be able to find, okay, the best way is just to split that into 2 and 2, and we'll be able to make $10. Okay, so yes, this is the way to get this way. It's definitely going to help us to get all the best way to cut the rod. But let me just ask you a general question. Okay, so here when n equal to 3, we have 8 ways or 8 possibilities to cut the rod. But what if n equal to, let's be general. Okay, when n is when n is 4, we got 4 different we got 8 possibilities. But let's just be general. Okay, what if we don't know what kind of value n is? We just know it's a variable. It can be any value. And here I'm just asking you, okay, how many ways or how many possibilities do we have to cut a rod of length n? So think about it. So if you need some time, feel free to make a pause when you are watching this video, okay? And spend a couple of minutes just thinking about it. So if you can find, if you have your solution ready, if you have your answer ready, and then resume the video, okay? So according to my previous experience with when I was teaching this course in the previous semesters, the most popular answer is this: 2 times n. Okay, 2 times n is the number of possible ways, because here when n equal to 4, we got 8 ways. 2 times 4 is 8. So yes, it works. It seems works, right? But actually it's not. Actually it's not. So let's check all the possibilities. Okay. So here, if we have a rod of length n, okay, so then we are going to get n minus 1 separators. By separators, I mean that the cutting points. So we can make a cut between the first inch and the second inch. We can also make a cut between the second inch and the third inch. So we got n minus 1 here. We got n minus 1. I'm just going to call them cutting points. We got n minus 1 cutting points. 1, 2, 3. Let's give them an index. So here we got the first cutting position or cutting place, and the second cutting place, third cutting place, n minus 1 cutting places. At each place we got 2 possibilities. The 2 possibilities are like if we cut it or not. Okay, so at each place we got 2 possibilities, and then so our decision at any place is independent from the decision at any other place. So which means that whether you make a cut at here does not depend on whether you make a cut over here. Okay, so they're independent. So then if you learn the core, if you know combinations, and so if your math is good, you'll be able to tell, okay, so if we have n minus 1 different say places to make a decision, and at each place we got two choices, and all these different places are just independent from each other. So in total we'll be able to, so the number of possibilities is this: 2 to the power of n minus 1. So here we got 2 to the power of n minus 1 possibilities. And let's double check if this works. When n equal to 4, this is going to be 2 to the power of 4 minus 1. It is 2 to the power of 3, and it is 8. Same, yes, it's correct. Okay, so here we got 2 to the power of n minus 1 possibilities. So here, if we just want to enumerate all the possibilities, all the possible like cuts and fake, so we have this number of possibilities, and so then we just need to calculate the revenue from each of these possibility. So in total, if we want to enumerate all the possible solutions, the complexity of that code would be at least 2 to the power of n minus 1, because we have to check each of these 2 to the power of n minus 1 solutions or possible cuts and calculate their revenue. Okay, and so previously we said that when we're talking about complexity, we want to eliminate the constants. So here we are going to say that we just remove the minus 1 over there, and then what we got is 2 to the power of n. Okay, so the complexity of this solution is going to be O 2 to the power of n. Okay, so now we learn a new complexity, 2 to the power of n, and here is the 5 complexities that we have learned from the lowest to the highest. Okay, from the lowest to the highest. So if I ask you to insert the new complexity that we learned today, 2 to the power of n, where should you put it? Okay, so should it put before O1 or between or right after O1? Think about it. So the correct answer is that you should put it over here. It is the highest. It is higher than any other thing. Okay, so it is higher than any other complexity that we have learned before. So if you don't believe that, let's just do some easy calculation. Okay, when n equal to 1, what is n squared and what is 2 to the power of n? So let's just enumerate all the possible things. Okay, what is the relationship between n and n squared and 2 to the power of n? When n is 1, we have n squared as 1 and 2 to the power of n as 2. Okay, so they're quite similar. At least they are all just single digit number. Okay, but when we increase n by 10 times, n squared is 100. So n squared increased by 100 times. What about 2 to the power of n? 2 to the power of 10 is 1024. Okay, so 2 to the power of n increases about 1000 times. What about when n is 100? So we got n squared as 10,000. Okay, so what about 2 to the power of n? 2 to the power of n is 2 to the power of say 100. So this is going to be something like, let me say, this is going to be something like 10 to the power of 30. Let me say if I'm correct. Yes, 10 to the power of 30. Okay, this is because 2 to the power of 10 is almost like 10 to the power of 3. So if we just raise it by 10 power 10, then yes, so 2 to the power of 100 is going to be similar to it's going to be a little bit higher than 10 to the power of 30. Do you want to know how large is 10 to the power of 30? It is 1 billion of 1 billion of 1 billion. Okay, so yes, this is definitely much larger than n squared. So actually, if we draw the plot that you have seen before, where n is, so the axis is n and the y-axis is the time, the execution time of an algorithm. So if this is O(n) complexity, and this is O(1) complexity, okay, and then this is O(n) squared complexity. Sorry, this is O(n) squared complexity. Don't know where is 2 to the power of n. 2 to the power of n is going to be this. It goes up extremely. It increases very quickly. So this is 2 to the power of n. So this complexity is very important in computer science, because people even give it a name called NP-hard. NP stands for non-polynomial. Okay, it's non-polynomial hard. So if you know a famous person named Alan Turing, so this person by himself just laid the half of the foundation of computer science. Okay, this person just spent, like, even though he passed away at the age of 30 or something, he's really genius. So this one is like the Albert Einstein in the world of computer science. And this person just designed this term named NP-hard, and he proved that the highest complexity that we can see is NP-hard, is 2 to the power of n. So actually this is the highest complexity you can expect. And so maybe you don't so still NP-hard is kind of like very strange to you, but so let me just translate it into human language. It means what? It means unsolvable. Okay, it means unsolvable. What does that mean? As long as n is larger than 100, it's going to, if you are giving a problem whose size is larger than 100, and if you are using a 2 to the power of n NP-hard algorithm, if the problem itself is NP-hard, then it will take at least 200 years for program, even though you use a supercomputer and then to run the algorithm, it will take at least 200 years for the algorithm for the program to finish. Okay, so by that time, all of us passed away. Okay, so unsolvable means it doesn't really mean unsolvable. It means unsolvable within a reasonable amount of time, like years. So this one is definitely not so here, if we have an input size of larger than 100, it will take more than 200 years for the program to finish, even on a supercomputer, the most advanced supercomputer in the world. Okay, so here you can say that, okay, and this complexity here, even so that if we want to enumerate other possible ways, and it's not going to be solvable or feasible. Okay, so it's not, so this one is not we call it not computationally feasible, meaning that you can like just put your program into code, but you won't be able to see the output of your code within your lifetime. So then people design better solutions to make the program more efficient, and that is based on dynamical programming. So here let's just look at this. Okay, so let me say let's go to this equation first. So we have Rn equal to the max of this. Okay, let's just look at this mathematical formula. Some of you may say, okay, what does that mean? So, but I'm going to explain it for you. Here we have Rn denotes, let me make it general. Okay, Ri means like any integer. I can be any integer from 0 to infinity. Okay, Ri means the maximum revenue to sell a rod of length I. Okay, to sell a rod of length I. So which allows you to cut the rod as many times as necessary. Well, Pi means the price of a rod whose length is I. So it's like if you have a rod of length I, if you sell it directly, this is the money that you can get. So here so people design the solution in this way. Okay, so suppose here, this mathematical formula is really beautiful. I'm going to explain it for you. Suppose here you have a rod of length n. We have a rod of length n. You are allowed to make as many as n minus 1 cuts. But now we're not bothering with all the cuts. Let's make the problem simpler. Let's just consider the leftmost card. It's like after you make this card, you are going to sell this piece in a whole, whereas you are allowed to further cut the right part. Okay, so that's why we say it's the leftmost card. Okay, so you're not going to make any card in the left part after this cut. Okay, so suppose here we make the leftmost card right over here, so which ends up with the first part, the left part with length I. And what about the length for the right part? Yes, its length is n minus I, because in total we got n inches, and for the left, if we got I inches, then the right one should be n minus I inches long. Okay, so because we are not allowed to further cut the left part, so we have to sell it directly. How much money can we make from that? It is Pi, right? So this is what we said, that the price of a rod of length I if you sell it directly. And then so let's say if after we make this the first cut right over here, and then we're allowed to further cut this part. Okay, so what is the maximum revenue that we can make from the right part whose length is n minus I? The answer is this, Rn minus I, because Ri represents the maximum revenue for a rod of length n. Here, because the length of this rod is n minus I, so we got Rn minus I. Okay, so if from the left part we solved for Pi, and for the right part we solved for Rn minus I, and in total we make Pi plus Rn minus I dollars. Okay, so this is the inner part over here. So this tells you, okay, if you make the leftmost card at this place, and how much money can you make at most? And then let's just consider all the possible ways of all the possibilities of all the possible places of the leftmost card. We can make the leftmost card as early as the place 1, and then we can make it at place 2, place 3, all the possible carding points. Or we can also make the leftmost card at n-1. In that case, we got a rod of length n-1, and we sell it directly, and also we got a rod of length 1, and we because we are not allowed to further cut it, we will also go to sell it directly. Okay, so actually there is one more option, that is we cut it at the last place. It means that we don't cut it, we just sell this rod of length n directly without any cut. So here we say that so we can make the first cut as early as the first place, but as late as the nth place. Okay, so because we want to make the maximum revenue, what we need to do is that we just enumerate all the possible places of the first cut, and then we say, okay, which first cut, which place of the first cut gives us the highest revenue, and then we will just go for that. Okay, so we make the decision of the first cut, right? So actually, so this mathematical formula just tells us the solution. Okay, so we're going to try all the possible places of the first cut from which is I from 1 to n, and then we figure out what is the revenue from that. Okay, so it is pi plus r n minus I. We're going to try all the possible I and then find the maximum. Okay, so the maximum revenue will be from the best left card. Okay, will be from will come from the best leftmost card. Okay, so this is the explanation of this mathematical formula, and this formula is just beautiful. It's really beautiful. So previously we got a really complicated problem, but this mathematical formula just with a very simple formula, it seems that we know the solution of this problem, right? Okay, so but actually we're not done yet. So so here what it does is so from this formula, let's first we need to talk about a few things. The first thing is that, okay, on the left hand side we have the optimal solution, or the highest revenue for a rod of length n. Well, on the on the right hand side we have the optimal solution for a rod of length n minus I. And here we need to note that I is larger than or equal to 1 but smaller than n, so this value is definitely going to be less than n, correct? Yes, it's in a range from n minus 1 to, it's in a range from 0 to n minus 1. So here what we can say is that on the left hand side we have the solution to the optimal solution to a bigger problem, whereas on the right hand side we have the optimal solution to a smaller problem, okay, whose size is smaller than n. So in this case we say that, okay, if you see a problem like this where the optimal solution of a bigger problem incorporates the optimal solution of a smaller problem, we say that this problem it shows the optimal substructure property. Okay, and so this is called the optimal substructure property, and this is, so you have to remember this property, because in your coding interview, after you receive the question or the definition of the problem from your interviewer, so you need to check if the problem shows this property. Okay, if it shows this property, then it means that you can. It doesn't mean that, it doesn't necessarily mean that you have to use dynamical programming, but it means that it's possible for you to use dynamical programming. Okay, But if this property is not satisfied, okay, you shouldn't even consider dynamical programming. No dynamical programming can be applied to that problem, okay? So so that's why I say this property is important, and I also put it in the previous slide. The optimal solution to a problem incorporates the optimal solution to related sub-problems, and okay, and this is called the optimal substructure property. So I don't expect you to remember this definition like word by word, but instead I want you to have a good understanding of it, and you should be able to tell this definition based on your understanding without just reciting it, because this is not a literature or history class. So so this is the first thing that I want to talk about, and here let me just so look at this. Okay, so let's just interpret this formula in another way. Okay, let's just say, for example, when n equal to 4, this problem, let's just expand this mathematical equation. It means that R4, the maximum revenue to a rod of length 4 is like this. The max between P, so let's start with I equal to 1. When I equal to 1, we have P1 plus R3. P2, then when I is 2, it will be P2 plus R2, P3 plus R1, and P4 plus R0, okay? So we just try all the possible, we just just calculate all these values and find out which one is the maximum, so we will return it, okay? So here what I want to show you is that, okay, so in order to know the maximum revenue for a rod of length 4, we have to enumerate the solution to all of its sub-problems of length 3, length 2, length 1, and length 0, okay? So which means this, okay, in order to figure out the optimal solution of a bigger problem whose size is n, we have to figure out the solution to a problem of size n-1, n-2, etc. until n, okay, until 1, okay? So this means that we are dividing a big problem into small problems, but we just reduce the size of the problem one by one. But unfortunately, these problems, let me just copy and paste this figure to here, okay? Dynamical programming. Okay, so if we have a very complicated problem, we need to enumerate all the possible, we need to first calculate the solution for its sub-problem of length n-1. So here we have a problem of n, size n. We just reduce the complexity by trying to figure out the solution of size to a problem of size n-1, n-2, etc. until 1. So here these are the sub-problems. So we are dividing a big problem into different sub-problems. These are the sub-problems. Not sub-programming, it's called sub-problems. Okay? So here we do see overlap between these sub-problems. So here let's just look at the first two sub-problems. They overlap at here, okay? There is an overlap between them, okay? So here, this is the difference between divide and conquer. If we are using divide and conquer, we divide a big problem into disjoint parts, disjoint sub-problems. But if we are using dynamical programming, we are dividing a very big and complicated problem into overlapping sub-problems. Okay, so this is the major difference between divide, conquer, and dynamical programming. So and then let's come back to the formula. Okay, so actually, if we want to, if a mathematician just work out this mathematical formula, so we as the programmers can just translate it into pseudocode or code in maybe like 30 minutes or so. So it's not difficult at all. So and this is the implementation of this. So this is the translation of the mathematical formula into pseudocode. Okay, it's just a direct translation. So I'm just going to write down the formula right over here. We have Rn equal to the max Pi plus Rn minus I. Okay, so here we're just defining the algorithm named color rod. So color rod takes two parameters, P and N. P is the price array, like over here. Okay, P is the price array, and N is the size of the rod that you have. So first we have, if N equal to 0, return 0. So what does this mean? If N is 0, it means that you have a rod of length 0. Okay, it's like you have nothing. And then, so if I ask you how much money can you make from nothing, then the answer is just going to be very easy. 0, okay? So yes, that's why we have this part. But otherwise, so it does, what it does is this. So first it has Q as negative infinity, and over here, so negative infinity may be relatively difficult for to understand, but let's make it a 0. Okay, first for I starting from 1, so actually if you substitute this negative 0 with negative infinity with 0, the output will be the same. So for I starting from 1 to n, Q equal to the max between Q and Pi plus cut rod Pn minus I. So here the cut rod this cut rod function is going to calculate the highest revenue for a rod of length n. Okay, so in other words, so cut rod, so if we call the function cut rod at P and N. So for now I'm just going to ignore P, the array P. I'm just only going to write N. N is the length. Okay, so it's very similar to here Rn. Okay, it's actually equivalent to Rn because it tells you what is the highest revenue you can make from a rod of length n. So here we can say that, let's just translate that Rn. So if we want to calculate Rn, first we have Q equal to 0. Okay, and for I start from 1 to n. Okay, Q equal to the max between the self and Pi plus cut rod n minus I, which is equivalent to R minus I, right? So okay, so this is kind of like this mathematical equation, and still for some of you it may like look very strange, but I'm just going to expand this for loop. So it's like when n is so let's take it this way. Q is the max between, so because sorry, it's not P, it is Q. This one is Q. Okay, Q is the max between its initial value, which is 0. Okay, because we have Q as 0, and so here let's first check what if I equal to 1. If I equal to 1, we have P1 plus Rn minus 1. When I is 2, when we just do another iteration, we have I as 2, so it is P2 plus Rn minus 2, etc. It will, at last it will reach Pn plus R0. Okay, so here basically we're trying to figure out the maximum value. So Q, finally Q is going to be the maximum value between 0 and P1 plus Rn minus 1, P2 plus Rn minus 2, etc. And here if we just use an example where n equal to 4, then Q is going to be the max between 0 and P1 plus R3, P2 plus R2, P3 plus R1, and P4 plus R0, which is 0. Okay, so here if you look at this part and this part, do you see anything similar? Okay, here we just add 0 to it, but since we can definitely make some money from a rod which has a positive length, we can just it's pretty free for us to remove that 0. So here what it does is that it basically enumerates all the possible places of the first cut, like what we discussed over here. So this function is going to calculate the maximum revenue of a route whose length is n, which returns Rn. So that's why I say this function just directly translates this mathematical equation into pseudocode. Okay, so into pseudocode, and so it seems that with this mathematical formula we solve this problem very easily. Okay, but actually no. So let me ask you a question. Okay, if we follow it in this way, how many let's just make continue example with r equal to 4. Okay, n equal to 4. Let's say how many times do we call this function? Initially we call cr4 in cr4 we are calling cr3, because in this loop we are going to call cr3, cr2, cr1, and cr0. Okay, for now let's forget about 0, because for the 0 case it's really easy. And then when you are calling this function with the same function with the input parameter 3, it is going to call cr2, cr1. And when you are calling cr2, it's going to call cr1. When you are calling cr2, it's going to call cr1. Okay, so here let's say how many times do we call this function? 1, 2, 3, 4, 5, 6, 7, 8. Again, 8 times. So this is like actually the performance or the efficiency of this pseudocode is going to be exactly the same as enumerating all the possible ways of cutting a route of length 4, and it's nothing fancy. So it's like even though this pseudocode seems cool, it still gives us the 2 to the power of n complexity, and this is something that we don't want. This is definitely something that we don't want. And and here what you do say is that okay, the problem of such high complexity is because we repeatedly solve the same problem multiple times. Look at CR2, we solve the same problem twice, and we solve the problem of CR1 4 times. This is something like, okay, if I'm the instructor, okay, I give you a homework to do for the first week. I give you one homework. For the second week, I still give you the same homework, and for the third week, I still give you the same homework. So some of the students may, let's say, after they receive each of these 3 exactly the same homeworks, they're going to work on them from the scratch, starting from the scratch. But the other student, but this would definitely take a lot of time from you, especially from like take a lot of time from you when you are playing video games, right? So it feels bad. So like, and those people, so I think most of the guys would say, okay, after you finish the first homework, you are going to say, okay, I'm going to take a picture of my solutions. So next time when you receive the same homework, you are going to, okay, copy and paste it, and then just submit that homework within 1 minute, so that you got more time to enjoy your life, right? Yes. So over here, okay, the problem of such a slow algorithm is because we are repeatedly solving the same problem multiple times, and we want to avoid that. The way for us to avoid that is by using dynamical programming, so which I'm going to introduce next. So like, so far I have been going over the slides for almost 1 hour. I think for most of you, your head may feel like exploding. And if you have this feeling, I'm pretty happy. Because this means that you are focusing, you are paying your attention. It means that I don't lose you. So that's great. If not, probably either it means that you are too smart to so that you probably shouldn't take this course, or it means that you are lost. And So last week I asked you to share your opinions with me regarding this course, and so I say that there either you can send an email directly to me, or you can just go to that famous website to provide your feedbacks. As of this morning, this is Tuesday morning, okay? As of this morning, I just checked that famous website. I don't find any new any new comment or rating from like recently, okay, from recent students. So it means yes, still you haven't. It means that still I haven't heard from you about your comments on this course. So feel free to do that if you want to say something, okay? And so besides that, I also want to talk about something that is that is kind of like related to this complexity, or to the part of n complexity. But I'm going to ask it in another way. Okay, so the answer is that suppose today, if you just receive $60,000 as a gift, what are you going to do with that money? So what are you going to do with 60,000 gift? Like, I think at your age, like again, this is based on my previous experience. At your age, especially for boys, like every semester when I taught this course, after I raised this question, there are definitely a couple of guys who are raising their hands saying that I'm going to shop for a car, I'm going to get a luxury car like Mercedes or BMW. So suppose today, okay, you just buy a luxury car. Let me just give you an example, like BMW 5 Series, okay, 5 Series. You probably can get it around $60,000. I don't know. And so do you know how much value it is going to hold next year if you buy it today? So for $60,000, how much value? So if you start it next year, how much money can you get back? 50,000 at most. And so this is year 1, okay? What about year 10? In 10 years, how much money can you get from that car? It's probably at most $10,000. At most $10,000. Like so like I'm not a I don't hate like European cars or German cars, but the thing is that they just do not last, and so that they're not that reliable, especially when time goes by. Like after 6 years, you have to spend a lot of money on maintaining them. So that's why their value their decreases very fast. And so this is one example. If you're so let's say here in 10 years you lose 80 you lose let me say how much you lose 50,000 out of 60,000. So and actually let's say so if you take this one, if you take purchasing a car as an investment, okay, so you know in 10 years so on average, okay, just on average every year you lose 15%. Every year you lose 15% of your value, okay, so of your value. And so in 10 years you're going to lose around, let me say how much, so in 10 years you're going to lose around 85%. 10 years you're going to lose 85%. So if you take this one as an investment, so the return is negative 85%. Okay, so some of you may say I'm going to get a luxury bag. So I don't know what kind of luxury bag is worth $60,000. I never pay any attention to that. So let's say you just buy it for $60,000. In 10 years, do you know how much can you get from that bag? Mostly likely 0 or maybe 5 cents, because nowadays if you go to a supermarket and if you want to get a bag, plastic bag, it costs you 5 cents. In 10 years, the value of your 60,000 luxury bag is going to have similar value as a 5 cent plastic bag. So in 10 years you lose 100% of your money. And then what if say some people say I'm going to so some people may say, okay, I'm going to invest it on stocks. So here I'm just not talking about a particular stock because it is too risky. So I'm just using SP 500 or Nasdaq as which is the index fund as an example. So if you invest SP 500 in general based on the historical data over 120 years, each year you can make anywhere from 6 to 8%, okay, on average. But definitely there are some good years in which you can make say 20%, but there are some bad years like this year probably you lose 10% of your money. But in general, like in longer term, every year in general you can get around 8%, okay, you can get 8% from that. Okay, so here the last one that I'm going to talk about is education. Okay, suppose that you use that money as your graduate study fund, like so you use that money to pay your tuition for graduate study, or just say for you go to some school, you keep educating yourself, keep learning new stuff. Do you know, like, if you how much money can you make from that? So according to historical data, and so if you stay in school, actually staying in school does not necessarily mean that you are learning new stuff. I'm just putting it another way. Okay, if you are investing investing on education, in each year of your education, okay, let's say if you spend one more year in school and you're really paying your time to learn something, okay, on average each year of school at school can increase your annual income by 20%. Okay, so what does this mean? Okay, so for each year it's going to increase by 20%. So this means that, okay, for every year, like if you hold a car, a luxury car every year, so here this is the value that you are going to get. Okay, 0.85 to the power of n, where n is the number of years. Okay, so this is the so if you invest 60,000 on a luxury car, and in n years, n can be anything from 1 to 10. So this is the money that you can get, 0.85. But what if you just go for I'm just going to write it down over here. Okay, it is 0.85 over n. But what if you invest on a stock? Okay, it is going to be, so since the annual return is going to be around 8%, so your value is going to be like this. Okay, 1.08 over n. And here, what if you invest on education? It is going to be 1.2 to the power of n. N is the number of years that you spend at school. So some of you may not have a good feeling. You cannot feel the difference between that. But I'm going to give you an example. Okay. So last weekend I just talked with a friend, so which is my previous lab mate. He also did his PhD at Stevens within the same lab as me, and we are under the same advisor. So, but he entered the program like 4 years later than me. Yes. So last week I heard from him that he just got a job offer from Facebook his job title is research scientist. So you may say, okay, this job title sounds wonderful, but actually research scientist is so this is just the title, but what he does is what he's going to do is still software engineering. They give him this title rather than software engineer, just because he has a PhD. So Facebook, so for anyone in Facebook, if they are research scientists, so you can take them as software engineers with a PhD degree. They don't do research, but it's fine. I think software engineer is the job that most of you are going to look for. So guess how large is his package? So think about it. So when I raise this question in class, actually our class, there are only 3 students who come to the face-to-face class. So some people say around $80,000 a year. One student said around 80, one student said around 100, and the other one said around 150K, something like that. But I'm just going to tell you what is his package. His package includes the following part: bonus. The bonus is $160K per year. Okay, this sounds a lot, but still there are more. Sorry, this isn't not bonus. This is called base, and for his bonus, it's definitely going to be higher than 10%, but it's going to be lower than 35%, 10 to 35%. Okay, so then the other part is that his stock. So for now, Facebook give him a stock that is worth $320K as the time of now, and they are going to give it to him within 4 years. Okay, so they basically use this way to make sure that the employees stay with them at least for 4 years. Okay, so in 4 years, so each year is around 80K per year. Okay, and then also they give him a sign-on bonus. Guess how much is that? It's $100,000. They're going to give, so since he just signed the contract, they give him 50K, and just 1 month before he start his job, they're going to give him the other 50K. Okay, so in total here, if you do some easy calculation, you can say that his salary, his annual income from Facebook is going to be around 300K, or to be precise, this is going to be around 280K. Wow, it's a lot, right? So yes, this is the income that he can get after a PhD, after staying 5 years at school with a PhD after his undergraduate study. So, but some of you may say, okay, what if you just don't get a undergraduate? So what if you don't get a PhD and just enter the industry as an undergraduate student? So as an undergraduate, so first of all, Facebook rarely hires software engineers who with a bachelor degree. Rarely. But just in case that you are fortunate to be hired by Facebook as a software engineer, and you're with right after you finish your bachelor, right after you finish your undergraduate study, your salary is going to be this, from 100K to 130K. That includes everything, because you are not going to get stocks. The sign bonus is going to be minimum around 20K at most. And so what you get is just base plus bonus. Okay, so here you can say that, okay, after because he just spent 5 more years at school and really learned something. Okay, what he got, he basically raised his income by 2.2 times to 2.8 times. I'm just going to use the number 2.8 times within 5 years. If you do some math, it is 2 to the power of 1.2 over 5. Here 1.2 over 5 it's just around 3.3. So this is very close to 2.8. Yes, this proves that, okay, the value of education. So what I'm saying is that nowadays a lot of people are saying that the richers are getting richer and the poor are becoming poor. Yes, it's true. We all see that, but it is because of what? It is because of the investment options or the lifestyles that different people choose. Okay, so suppose today you got some money, you just received a paycheck. If you use that paycheck for something like enjoyment, for example, you just buy a big brand shoes, a pair of brand shoes for $200, or say you just buy a iPhone for $1,000, and then let's the value of your investment is going to be 0.85 over n. So if we plot that one, again this is n and this is the value, okay? So this is 1, okay? 0.85 is going to be something like this. Okay, when time goes by, your value is going to be very, very close to 0, okay? It definitely drops. But what if you choose a different way, or say you're investing on stocks, or you are investing on yourselves by you're reserving your enjoyment, okay? You're not going to enjoy that kind of immediate happiness, but you're just going to like invest on stocks or invest on yourself by going to school, okay? So this is going to be, I'm going to draw this picture, okay? This is 1.08 power n, and this is going to be 1.2 power n to the power of n, okay? So with time goes by, the difference between these three people or between these three different choices are going to be extremely large. It's going to be, the difference between them, or the gap between them, is only going to be wider and wider and wider, okay? So say if those people, if they choose to go this way, use their money for short-term happiness, either buying a luxury car, luxury bag, or just buying a luxury phone, this is their choice. They are only going to decrease in value. But if you just make a better decision, you will be able to enjoy the happiness, the much bigger happiness later in your life. Okay, so this is the thing that I want to talk to you. Okay, this society is pretty fair for everybody. Okay, so you have the choice. Say for example, in March the government gave 1,200 to most people whose income is lower than threshold value. So yes, what I say is that right after that, I see a lot of people just going to Walmart and buy those big televisions, or buy some luxury shoes, whatever. Yes, they are going this way, okay? But you shouldn't. You should go this way, okay? And those people should not complain. They don't deserve to complain because they make that choice. I don't feel sorry for them, to be honest, because that's their choice. No one forces them to buy those things that will only decrease in value. Okay, just give you one example. So I'm not going to tell you how much money do I make, but it's definitely higher than most people, maybe 90% or 80% of the people in the US. Like, still nowadays I'm using my iPhone 6s, which I bought maybe 4 or 5 years ago, and I'm just again, and also I never buy any pair. All of my shoes are lower than $50, and all of my clothes are, except for the winter clothes, winter coat, all of them are below $50 too. Yes, I live in a conservative way, but what I do is that my daughter is only 2 years old, and I saved around 20K in her college fund to make sure that she can go this way. Yes, I hope that you can make similar choice in the future when you become a parent. Be a responsible person who can give your child a great future. Okay, so yes, I hope that this talk can give you some insight or can give you some value, and also can bring your attention back. Okay, wake you up if you fall asleep from my previous slides. And so let's come back to the content. Okay, so we said that the main problem with here is that with this solution is that we're repeatedly solving the same problem multiple times, and to resolve the problem we don't want to repeatedly calculating them. Instead, we're using dynamical programming. In dynamic programming, what we do is that whenever we solve a problem, we store it. In the first time we solve a problem, we store the solution in the memory. And next time, if we are asked to solve this problem again, we're not going to work on it really. We're just going to retrieve the solution from memory directly. So, and this is the code to do that. Okay, this is the function to do that. Okay, so it's called memoized color rod, and it has two parameters, p as the price array and n as the length of the rod that you have. So here we have let r from 0 to n be a new array. So we are creating an array r. So if you remember, ri stands for the highest revenue for a rod of length I. And for I starting from 0 to n, so first it give it a negative infinity value. So here you can also give it a 0 value. So it's like we have the solution for everything, for the rod of every length from no, let's just do not give it 0. Let's just give it negative infinity. It's like without looking at, we haven't checked the revenue that we can get from for any rod, for a rod of any length. So we just assume that for a rod of any length, we can make nothing from it, and the value of them is just negative infinity. And here then it calls this function to calculate the auxiliary function to calculate the highest revenue the solution for a rod of length n. So what this function does is that if Rn is larger than or equal to 0, it returns n. Let's put this one later, and let's just focus on the next part. If n equal to 0, we have q as 0, okay, and after that it will store q at Rn. So if n equal to 0, it's like we're going to sell a rod of length 0. So the money we can make is 0. So that's why we have q as 0, and then we just store the solution at R0. Okay, it's like R0 equal to 0. So it's like telling us the highest revenue for a rod of length 0 is just $0, and then we just return it. Okay, and otherwise we first set q as negative infinity, and then we just for I starting from 1 to n, q equal to the max between the self and pi plus memoized color rod auxiliary function with p n minus I and r. So this auxiliary function, we can take it as Rn minus I. We can take it, for this part, we can take it as Rn minus I, and this is going to be quite similar to here. Okay, so we're basically replacing we're just giving the function a new name. So here what it does is that it try all the possible places of making the first cut, and then so find which place of the first cut gives the highest revenue. Okay, so then it just does the calculation. For this part, just to calculate Rn, and store it in Q. Okay, Q has the value of Rn, so we just store the solution at Rn and return it. So let's come back to here. Okay, if Rn is larger than or equal to 0, it means what? It means it's not negative infinity anymore. It means that we have for the rod of length n, we have calculated the solution before, and we store it at Rn. So if it's larger than or equal to 0, it means it's like, okay, when you are receiving a homework, you are just checking, okay, the previous homeworks that you have done. If you're just receiving at the time when you receive a new homework, you're just checking the historical data to say if you have done this homework or before. If yes, you just copy and paste that. Okay, so here if Rn is larger than or equal to 0, it means that we have calculated the solution of Rn before, then we just return it. So this is how dynamical programming works. And actually, besides the biggest difference from the previous simple version called color rod is that here we're creating a new array to store the solutions, or to store the solutions to the homeworks that we have done before, so that next time when we receive a repeated homework, we're just going to copy and paste that. So this is the general idea of this is the application of dynamical programming on the rod cut problem. And so there is another way called bottom up. So this bottom up is like, first it calculates R0, and then it calculates R1, and then R2. So it gradually increases the size of the problem until it reaches Rn. So that's why we call it bottom up. And this is another version of the algorithm, but the idea is pretty similar to before. Okay, so to before. Okay, so here I'm just going to talk about two more things. The first thing is that here, if we want to infer the complexity of the algorithm, okay, we say for the first time we learn a concept called time complexity and space complexity. This is because previously we only care about time. When we're doing sorting when we're sorting an array, we basically arrange all the numbers inside the same array. We never allocate any new space. So that's why we say we only care about the time performance of the algorithm. So previously, all the complexity we talk about is time complexity. For this algorithm, the time complexity is going to be O(n) squared. But for the first time, we learn something like space complexity. Space complexity is something like when you are executing the program, how much memory do you expect the program to occupy in your computer? And here, the thing is that we are allocating an array of size n+1, an additional array of creating an additional array of size n+1. So like when we are running the algorithm, besides the input, we are also expecting to consuming n+1 memory spaces, and so that's why we say the space complexity is O(n). So it's linear to the, or you can take space complexity as how much memory space, the memory space that the program is going to occupy. So the memory space the program occupies is going to be linear to the size of the input. Okay, so here also from the n squared time complexity, you can see that with the help of dynamical programming, we reduce the complexity from NP hard or mission impossible to n squared. And this is a big improvement. So, and also at last, so the other point that I want to talk about is that actually if you implement this algorithm called extended bottom up, so the array S is going to tell you where should you make the cut. So for example here, if we have an array of so if we have a rod of length 4, R4 tells us, okay, the highest revenue that we can make is $10, and S4 tells us where you should make the cut at a rod of length 4 in order to receive the highest revenue. It tells you that you should make a cut at the second place, so that you got a rod of length 2 and 2, which gives you $5 each, and in total is $10. Okay, and you are not required to implement the extended bottom up function, but if you implement that, you will be able to get some additional credit too. So, and after this lecture, I require everybody to read chapter 15.1. Okay, this is the first time that I require all of us to read something. Okay, previously I said that you should read it, but I never say you must read it. So this is the first time I say you must read it. Then I rarely ask for make this kind of request to my students, and for this time you had better obey it, because again, as I have to repeat that dynamical programming is the topic that decides if you can be a software engineer or not. Okay, you don't want to shut that door of your career too early. So pay your attention, read this subchapter, and have a better understanding of dynamical programming and succeed in your future job interviews. Okay, so actually in dynamical programming, the textbook provides 4 problems. The first problem is called rod cut, which we discussed today. The next problem is called matrix multiplication. Okay, so that one is more complicated than rod cut. And then the other one is called LCS, and the last one is called optimal binary search tree. Okay, so I'm going to talk about this one. This is this week. I'm going to talk about rod cut this week, and LCS is for next week. Okay, for matrix multiplication and optimal binary search tree, I'm not going to talk about them in class, because I don't. So they're really difficult to understand. But again, if you want to if you are serious about the career as a software engineer, go to read it by yourself. And also I provide the slides for these two topics. So you can first go through the slides and then read the book chapter. Okay, so this is our lecture today. And also what I want to ask, I have one more question for you. So it is okay. Next Monday, which is, if I remember correctly, it is October 12th is Columbus Day, and the Montclair is going to be closed for that day. So which means that we're not going to have face-to-face class next week. So my question is that, okay, so do you want me to skip that week, meaning that I even don't upload new stuff to Canvas, so that you have one more week to catch up everything that you have learned so far? Or do you want me to continue as usual, like say just uploading uploading video lectures and continue as usual? So next week you will receive a new homework to work on. So depends on you. Let me know your opinion. Okay, let me know what kind of choice do you want to make. And actually I'm going to create a doodle survey. Okay, I want to hear your opinion about that. If you need a break, if you need a 1 week break, feel free to ask for that, because we are quite on track of finishing all the stuff on time. So we have that space. So if you have a lot of midterms and you need to prepare them, and you need some time to prepare them, feel free to say that you want a break. Okay, so that's it for today.